Hi guys, Mr. Rocco here. I hope you're having a good weekend. We have one more section on this part of topic 5 to cover on weather, and that's fronts. So let me get started. A front is a boundary, or this word we had way back in the beginning of the year, an interface. An interface is just also another way of saying boundary, like the door would be an interface between my classroom and the hallway. So a front is just a boundary or an interface between two different air masses. Last week, hopefully you watched that video on air masses, and there's the 5 basic types of air masses, like maritime polar, which means cold and moist, or maritime tropical, which means warm and moist, or continental polar, which means cold and dry, continental tropical, which means warm and dry, and continental Arctic, which means very, very cold and dry. So a front is just a boundary between two of these air masses. And this is a typical weather map if you ever look at a website like the Weather Channel, showing you these boundaries. The good thing is the symbols for the fronts are listed in your reference table on page 13, in the same section as the same information on air masses and station models. They're also down at the bottom of that page 13. And so you see here some different types of fronts, like I'll circle some of these. You've got a cold front here, which has these blue triangles. You've got a warm front right here, which is these little red semicircles. So those are a couple of examples. So let's start with a cold front. So a front is named for what air mass is doing the moving, is pushing in toward the other type of air. So a cold front means the cold air is advancing. The cold air is what's pushing in, and that typically is going to be your continental polar air. So it's cold and dry, which comes down from Canada. And so as a cold front approaches New York State, let's say, or the Northeast, it's cold, dry air. This continental air is going to try to push in to meet up with warm air, a warm, moist air, which is maritime tropical. So the cold air is advancing, the warm air is retreating. Again, as you know, cold air is more dense, warm air is less dense. And so it's very easy for cold air to push the warm air out of the way, because it is more dense, cold air. And so that's a cold front. When you look at a cold front from a side view, so you got the surface of the Earth, right here, and this is the cold, dry air back here. This would be your continental polar air, which is now going to start to move. In this picture, it's going to move from left to right. And so the cold air is advancing. Over here on the right side of the diagram is your maritime tropical air. That's your warm, moist air, which is less dense. So you have more dense air back here behind the front, and you have warm, less dense air in front of it. The cold front is actually this arc, and that's very important. When they draw symbols, and this will come up on your test this week that you're going to take on Castle Learning, the symbol for a cold front is always going to be an arc. It's going to be this curved line that you see right here. So just be very careful when you're looking at questions, especially on the test this week. Cold front's always going to be an arc. That's going to be different than a warm front, which I'll get to in a few minutes. So you've got this cold front right here. This blue line represents the cold air. So that's the cold front itself. Here's the symbols. And again, you don't have to memorize the symbols. They are in your reference table. But they use these triangles. The triangles are always drawn facing the direction the air is moving, which in this case, it's moving from left to right in this picture. So you'd put the triangles on the right-hand side, which means everything's moving in that direction. If you had put the triangles on the left side, the front would have been moving that way, toward the left. But normally it's put on the right side, which means it's moving from left to right. Anyway, you've got this cold, heavy, dense air meeting up with this warm, less dense air. Well, that causes what they frontal lift, and that's what meteorologists will say. The front, this blue line, is going to cause this warm air right here to lift right up over the front. And when that happens, Of course, now you start the process of cloud formation, which hopefully you know. This warm air is going to go through all the steps. It's going to rise, it's going to expand, it's going to cool, it's going to condense, and it's going to form your clouds. And that's what it says here. Clouds develop because of the frontal lift of the warm, moist air. So this cold air pushes in, this warm air gets lifted off the Earth's surface, and then starts to go through that whole process of rising, expanding, cooling, condensing to form clouds. Typically with cold fronts, because this lift is very, very fast, cold fronts tend to lift this warm air very quickly. You're going to get usually severe weather with cold fronts. Things like thunderstorms or really heavy downpours of rain. In the winter, you might have a snow squall. A snow squall would be like it's sunny one minute and all of a sudden it's dark, dark clouds and all of a sudden heavy, heavy downburst of snow. You can drop a quick inch or two in a matter of a half hour. Where you have whiteout conditions. So that would happen in the winter. Of course, thunderstorms happen often in the summer, and that's all because of this cold front. This chart, and I post my notes on Canvas, so you can always look at these notes as well. This shows you three things. What happens before the cold front gets to you, as the cold front is on top of you, and after the cold front hits you. So typically, before the cold front gets to you, right, it's going to be warmer because you're sitting in that maritime tropical air mass. Then the cold front gets to you, the temperature starts to drop quickly, and after the cold front passes by your location, it gets colder. Pressure is going to be down a little bit in the beginning because remember, warm air is less pressure. Then the pressure after the front passes you is going to start to go up because the pressure, cold air is high pressure, so the pressure will rise. Winds in front of it are going to be out of the southeast, that's your warm air. As the cold front gets to you, the wind is kind of gusty and coming out of all different directions. And once the cold front passes you, again, that's bringing down that cold air from Canada that's coming out of the west or northwest. Precipitation, you might get a little bit of showers before the front. Not much precip, though. The heavy precip with the cold front is always when the cold front comes in contact with you. So as soon as the cold front hits your location, that's when you get the heavy rain, the heavy snow, hail, which you might get with a thunderstorm, things like that. And then after the cold front passes, it's going to clear out very quickly. And then this just shows you the types of clouds. You got your cirrus, your cumulus, and your cumulonimbus when it gets to you. This shows the same thing again. So you got this cold air mass back here. Again, an arc is always going to be the symbol for a cold front. This curved line. This warm maritime tropical air, which is going to lift right up over the cold front as the cold air pushes the warm air up. And again, you're going to get that rising, expanding, cooling, and form these really tall cumulonimbus clouds, which give you those thunderstorms, especially when we get into the warmer months like June, July, August. This is showing you, which is very typical of cold fronts, you're going to get tornadoes. Tornado season is getting closer. We don't get a lot of tornadoes around the Rhinebeck area, but places like Oklahoma, Texas, Arkansas, Kansas, places like that, Missouri, they're getting closer to tornado season. It's usually going to happen as we approach spring. That's because we're coming out of winter, right, and summer's coming in. So you've got warm air trying to push in. You've got cold air kind of trying to come down out of Canada, and the two air masses will collide. It's typically going to be your continental polar air, which again is coming from Canada, cold and dry, and you've got your maritime tropical air coming out of the Gulf of Mexico. These two air masses will start to clash with one another, and it's in between where the two air masses meet. That's where you're going to get those thunderstorms. This is showing you a typical radar, what they look at when a tornado is happening. They look for a hook, or it's not written down here, a hook echo. So what it is, you'll see this red. The colors, if you ever look at a radar, indicate cloud height. So blue is going to be low-level clouds. Green, the cloud tops are getting higher. Yellow, even higher. Orange, higher. And red are going to be your highest cloud tops. So like reddish color might be clouds that are up about 40, 50,000 feet into the atmosphere. Whereas green might only be 10,000 feet. So you're going from a 10,000 foot cloud top to a 50,000 foot cloud height. And so what typically happens is you'll get this little hook, and you can see it right here where this kind of hooks around like that. And again, remember, tornadoes are low pressure, so the center would be here, and everything's going to spiral around counterclockwise like that around this center of the storm. And so you get that little hook right there. And so meteorologists will be looking at the radar as a cold front's coming through, let's say. They know there's a good chance that you might have tornadoes. They're looking for this nice little hook right here. And right away, once they see that hook, they're going to issue a tornado warning. That doesn't necessarily mean a tornado's on the ground. You could have, let's say this is the ground, you could have a funnel cloud happening up here in the atmosphere, and slowly that circulation is going to eventually, that spiral is going to touch down. So then you have to send your spotters out. So they have the tornado chasers that go out and are now looking for touchdown. So you might have a funnel cloud up here above your head, but it's not technically a tornado until that funnel cloud actually reaches the ground. Sometimes funnel clouds will happen above your head. The cloud, you'll look up and see this awesome looking circular cloud spiraling. The cloud will spiral up here, but then all of a sudden get sucked right back up into the atmosphere, never reaches the ground. Then technically it wasn't a tornado. It started to form a tornado, but it just never came to be. So the radar isn't going to show you that, though. The radar is just going to show you that rotation. Then they have to send out the weather chasers, the storm chasers, to actually see if tornadoes hit the ground. Very dangerous job. I don't recommend doing it unless you are a little bit crazy, I guess, because that's a crazy career to have where it's just risky. You're always risking your life going out there chasing tornadoes. But can be a very strong adrenaline rush, that's for sure. All right, then you have your warm fronts. So again, a cold front, remember, is named for the air that's moving. So in a cold front, the cold air is advancing. In this case now, because it's a warm front, it's the warm air doing the moving. So the warm air, which again is that maritime tropical, is going to try, and I stress the word try, to push out the cold air. Now again, if you know, recall density, warm air is less dense than cold air. So it's not going to be easy for warm air to push the cold air out of the way. And you'll see that when I go over this side view here. Here it is. So you have a different kind of line here. If you remember, I'll draw it up here. Let's say this is the ground. A cold front is always going to be an arc like this. This would be cold air. So CP, continental polar, MT. This maritime tropical gets pushed right up over the front. It's very easy for the cold air to push the warm air. But now with a warm front, different situation. Warm air can't go under cold air, right? Because warm air is more dense. So instead of going under the cold air, the warm air has to slowly ride up over top of the cold air. And so here they don't use an arc. With a warm front, it's always going to be a very shallow, straight, slanted line. So you see this red line right here? That's a warm front. So you've got to try to remember that, especially for the test this week. Cold fronts are an arc. Warm fronts are always going to be a straight, shallow line, straight line like that. And there is always going to be a difference there. And so what happens here is this warm air, because it can't go under the cold air, it slowly kind of chugs uphill. Very slow incline. And so you don't get a rapid cloud formation. What'll happen is the actual warm air, if I draw a line, is right here. See where the symbols are for the warm front with these half circles? This is where the warm air actually is. But as the warm air slowly rides up over this cold air, which is sitting down here at the ground, it's not a fast cloud formation. The clouds will form. The front is, the cold air is lifting the warm air above it, or the warm air is kind of riding up over the cold air, but it's very, very slow. And so you don't get severe weather with warm fronts. You'll get showers, some light rain, but it'll happen way out ahead of the warm front. See, a cold front's different. A cold front, the precip's going to happen right on the front. Let me go back just to show you that again. Okay, so in this picture, notice where the clouds are. They're happening right on the front where the triangles are. Exactly right here would be where the rain is happening, or thunderstorm. But with a warm front, it's not happening until way out here. The difference between this line and these clouds between here and here could be, a couple hundred miles and a few hours in advance, several hours in advance. So you will get rain, more showery kind of situation before the warm air actually gets to you. And so that's the difference. It's going to be a slow incline, not a rapid rise. So this chart, which is now talking about warm fronts, again, it's in my notes, so if you want to go back and refer to it, you'll have cool air before the front gets to you, the warm front. All of a sudden, it'll start to warm up and then kind of level off. Pressure, again, is going to go down a little bit. It's going to level off. You might get a little bump and then a decrease, because remember, warm air is low pressure. So as the warm air slowly pushes in, the pressure will start to go down. The winds will be south to southeast, and then after the front passes you, south to southwest. So still basically same direction. Precip, again, you'll get some showers, some drizzle out ahead of it, but notice after the front, or even on the front, when the front gets to you, it's not much. It's a very light drizzle, if anything, and then no precip. But most of the precip is out ahead of, prior to the warm front getting to you. And then you can see your cloud types there. It says cold fronts and warm fronts typically form out from a low pressure. So when you look on a weather map and you see a big red L, those are the ones that are going to have the fronts. High pressures, when you look on a weather map and you see a big blue H, remember, high rhymes with dry. Dry air doesn't have any precip around it, right? No clouds. So you're not going to have any fronts coming off of highs, only off the low pressure. And they're going to look like spokes on a wheel. And if you recall the direction, circulation around a low pressure, they're going like this. Oops, let me use a different color. So they're going in and counterclockwise like this. And that's what's going to happen. The fronts are going to move around a low pressure in a counterclockwise direction, like spokes are going around a wheel. And again, here's a typical map off the Weather Channel. Here's your low pressure right here. So there's the center. That's like your pivot. All right, everything's going to rotate around this L right here, this low pressure, and it's going to go counterclockwise. You see the yellow arrows showing the direction the fronts are going to move. So you've got basically, and I'll cover this again on this video, you've got three air masses here. They call them sections or sectors. In this section right in here, I'll kind of highlight it, this would be your maritime tropical air. This is coming out of the Caribbean or the Gulf of Mexico. So these two air masses are bringing air up this way. That's in this section. Up here above, this is a warm front right here, where you see these semicircles. Above it, right in this sector, would be maritime polar air. That's also wet, but it's cold air coming off the North Atlantic. So that's coming in from the east going this way. And then back here, notice all these high pressures, these big blue H's. This is all that continental polar air, cold and dry air that's coming down from central Canada, pushing this way. And it's going to be behind this warm front. And so you've got three air masses. The maritime tropical air, again, that was kind of messy. Maritime tropical air is pushing this way. The maritime polar air is pushing this way. And the continental polar air coming down out of Canada is pushing this way. But all going counterclockwise. So this warm front is going to push north. This cold front is going to push east. All rotating, kind of, again, pivoting around the center of this low pressure. And that's a very good, typical, standard low pressure system. That's what you're going to see 99% of the time. Now, what actually happens is, let me go back to that slide, sorry. Cold air moves faster than warm air. And so you've got cold air sitting here behind this cold front. You've got warm air sitting right here behind this warm front. This one's pushing this way. Again, this cold air is pushing this way. Not the tail end of the cold front. So this part of the cold front will never catch up to this part of the warm front, because remember, everything's rotating this way, counterclockwise. This cold front section down here at the bottom end and this warm front will never be able to catch up to each other because they're too far away. However, up here, closer to where they're pivoting, right around this low, this section of the cold front can actually catch up to this section of the warm front. And again, it's because cold air, being more dense, can move a lot quicker. And so this part of the cold front will actually catch up to this part of the warm front, and they will actually merge. And so looking at it, this is a top view. What'll happen is up here, the air is kind of cool. It's not terribly cold, but it's you know, cool means yeah, it's not warm either. This air mass back here is the cold air, right? So if you say, what's the difference between cold air and cool air? Cold would be obviously a lower temperature. Cool is low, but not as low as cold. And so these two air masses are going to actually join forces. In here, in this little triangle, this section is the warm air. So you've got warm air here. That's going to get squeeze plate out of the way. This cold air will catch up to that cool air. And again, this air inside here is going to get lifted up to form, of course, clouds and precip. And you can see all the rain happening right there along that cold front. So now you form what's called an occluded front. Part of the faster cold front catches up to part of a slower moving warm front. And again, cold air moves quicker on the surface because it's more dense. Warm air can't move as fast. It's lighter, so it doesn't have as much energy, as much force to slide across the Earth's surface. But the cold air can catch up to the warm air. And so that's what's going to happen. So again, this is kind of an animation, although it's not really animation, just kind of showing you in sections. So you've got this part of this cold front, this part of this warm front that are going to catch up to each other. So here's picture one. You see they're not connected yet. The tail ends, they're too far apart. Again, these sections will never catch up to one another, but up close to where they pivot, they will. So if I go from picture one to picture two, they're getting closer to picture three. So what happened here is, if you go back to the first picture, you only have two fronts over here. You have a cold front, you have a warm front. Here you still have only two fronts, cold front, warm front. Here you have three fronts. You still have a little section of a warm front. You still have a little piece of a cold front, but now the cold front and the warm front merged. And so how do they draw the symbol? They draw it on the same side, they just alternate symbols. So a cold front is triangles, a warm front is little half circles, they just draw them opposite, alternating. So you would have a triangle, half circle, triangle, half circle, triangle, half circle, etc. That's an occluded front. So, I'll clear all this. You got three fronts here. Again, here you have two fronts, 1, 2. Here you have two fronts, 1, 2. Here you have three fronts, 1, 2, 3. And they'll ask you a simple question I've seen on a Regents. They'll give you a picture. Well, they won't label them warm, cold, occluded. They'll just say, how many fronts do you have over here? And you just have to look at the fronts and the symbols carefully. So I can see here, it's just semicircles. That's 1. Check. Here I have just triangles. That's 2. Check. Here I have triangle, circle, triangle, or triangle, half circle, triangle. So that's how I know I have 3 fronts here. And you can see that here as well. So over here is, again, just 2 fronts. You've got cold, dry air. That's your continental polar. You've got warm, moist air. That's your maritime tropical. You've got cool air, like I said before, up here. This would be maritime polar. And notice how they're rotating, all going counterclockwise. This part of the cold front and this part of the warm front are going to catch up to each other. And that's what you see when you get to this picture over here. You still have a section of cold front. You still have a section of a warm front. So you still have a little wedge of warm, moist air in here. This would be maritime tropical, but not as much as you had here. Okay, over here, you had a big section of maritime tropical, warm, moist air, MT. Here you have less warm, moist air, maritime tropical. And now you've got cold air here and cool air here. And you notice up here close to the front, or close to the low, you've got that occluded front. So now you went from 2 fronts, 1, 2, to 3. 1, 2, 3. And again, everything pivoting counterclockwise around that low. This shows you a side view. So remember, again, a cold front's always an arc. So this blue line represents the cold front. It's labeled. This slanted line, straight slanted line, is the warm front. See how it's labeled? You've got cold air here. That's going to push this way to the right. This cool air is actually going to keep moving this way, but it's not going to move as fast. This is of the 3 air masses. You got cold. Here's warm air in between, and the cool air over here. Of the 3 air masses, this is the one over here. This cold air is going to move the fastest, and that's why it'll catch up to this air. And this warm air is like, if it could talk, would be like, whoa, I'm stuck in the middle. I'm getting squeeze plate here. And that's essentially what happens. This cold front's going to move this way faster. This cool air is still chugging along, but not as quick. The warm air gets stuck in the middle, and it's going to end up here. It's going to get shoved up upward out of the way as these 2 fronts, the warm front and the cold front, merge. And that's what you see here. So you've got this cold, dry air that pushes in fast. This air is the cool air. I wouldn't even say cold. I would say more cool. It can stall out or move very slowly. And then the warm air was in the middle here that gets shoved up out of the way. Again, you're going to get some heavy showers with an occluded front. Not violent weather. You're not going to get thunderstorms or anything with an occluded front. But you can get heavy, heavy, heavy rain once the cold air, the cold front and the warm front kind of merge with each other. And that just shows the symbol there. So it's triangle, half circle, etc. as these two air masses combine. So you had the cold air, the cool air combine. The warm air was in the middle, gets pushed up out of the way to form your clouds and your showers. This, I'm trying to see if this was a map from last year. You can see the date, February of last year, that I pulled off the Weather Channel. I'm just trying to see if there's an occluded front. I don't remember if there is. I know there's a cold front. Here's a cold front. Here's a warm front. Here's another storm coming into the West Coast, California. And you can see it's got a cold front on it. It's got another cold front up above. This front here, okay, and this front here is not a cold front. You can see, I don't know if you can see that carefully, a little difference there. That's going to be the fourth type of front. You notice the triangles, and they do alternate triangle, half circle, but look at the direction they're pointing in. If you can look at, especially this guy right down here. This would be, let me see if I draw a line here. You've got triangles like this. You've got half circles like this. Now that's not an occluded front. An occluded front had triangle, half circle, half circle. Notice the difference between this one and this one. They alternate, but this one, they're on the same side of the line. They're facing all the same direction. This one, they're facing opposite directions. The triangles are pointing down. The half circles are facing up. And again, they're listed in your reference table. You just have to be careful. This kind of front is not occluded. Kids will confuse that sometimes. Say, oh, Mr. Rocco, there's an occluded front. I'm like, no, that's actually a stationary front, which is the last type. So in a stationary front, the word stationary means to stay still, right? If you are stationary, not stationary like to write a letter, that's different stationary. Stationary means to stay put. And so what happens is, you have two air masses here, but notice the wording I'm using. I'm not using cold air and hot air. I'm using cool. And again, cool air means it's not as cold. Like cool air might be, I don't know if I had to put a number on it, cool air might be in the 40s. And it's going to meet up with warm air. Now, I'm not saying hot, sticky air like July air. Warm air might be in the 60s. That's not a big difference. You're talking 20 degrees, right, between this air mass and this air mass. That's not a drastic difference. They're very similar in temperature. I mean, 40s is not that bad, right? You're not freezing cold. And 60s isn't like, ooh, beach weather. So you've got two air masses. One is cool. One is kind of lukewarm. Neither one is going to have enough energy, enough force to push the other one out of the way. And so what happens is cool air is going to come down from the north. Warm air is going to try to push up from the south. But because these air masses, again, this is in the 40s and this is in the 60s, they can't push each other out of the way. This one can't go that way. This one can't go that way. They're going to kind of sit. And this could happen for days and days and days and not move each other. They're going to just kind of push into each other. You're going to get rain that lasts for several days. And they call that a stationary front. And that's what you saw. Let me go back. That was here. And there's some other stationary fronts, I think. This was a stationary front in here, too. And so that's very common. You get them. We get them, especially in April. Right? There's an old saying with April showers bring May flowers. So when we get into the month of April, and let's say we have, a week where, Monday it's raining, Tuesday it's showers, Wednesday is raining, Thursday is raining, for the first 4 days of the week, and students will come into my classroom like, gosh, when is the sun going to come out, Oh, maybe by Friday we get lucky and we get some sun. But the first 4 days of the week, it's kind of rain. Probably what's happening is there's a stationary front sitting over Rhinebeck. And that's what's happening. This, I wouldn't even use the word cold here. I would say cool. So this cool air is trying to push this way, south. And that's why you see with a stationary front, the symbols, again, are drawn on the side the way the air is moving. So when you put the triangles, you're going to face them pointing south because the cold air, right, comes from the north, makes sense, and cold air is trying to move south. Just like the little half circles represents warm air. Well, warm air comes from the south, places like Florida, and tries to push north. And so that's very common where you'll see triangles facing south, half circles facing north, and again, they alternate. But again, don't confuse that with occluded. Occluded, it's because the two fronts catch each other, so they're on the same side. It's going to go triangle, half circle, triangle, but same side of the line. They're moving in the same direction. So you've got two air masses moving together. This, they're moving in opposite directions with one another. And so here what you see is this cool air would be back here. Again, this might be in the 40s. And this air is pushing from left to right. This warm air might be in the 60s. This air is moving from right to left. So they're kind of pushing against each other. But again, neither one can shove the other one out of the way because one is not stronger, really much stronger than the other. And so they'll sit for days and days and days. And again, you'll get some lift. You'll get some clouds. You'll get a lot of showers. And that's typical, like I said, even end of March, the second half of March and into April, we tend to have this kind of showery event. Sometimes what has to happen, I've had students say, well, how do you get rid of a stationary front? Is it just going to all of a sudden decide to move off to the east and eventually clear out? Sometimes you need another front, like a cold front. Might be back here. This would be just triangles. This, another storm, you have a low pressure here. This storm might kick this one out of the way. So this will push in. This will get finally shoved out of the way and off into the Atlantic. And then this storm will come in, but keep on moving because these will move fast. Cold fronts tend to come and go pretty quickly. And so, but you need some other system to kind of push the stationary front out of the way. And again, that's very common in March, April. All right, so again, a typical cyclone. Remember, cyclone means low pressure. So when you look on a weather map, and I've gone over this already in the video, so I won't spend too much time. This is very typical of a low pressure, everything going counterclockwise. So you've got this little section in here is your maritime tropical, going this way. Up above the warm front, here's a warm front, is your maritime polar. That's cool, wet air coming in off the Atlantic. And then again, you've got your continental polar, cold and dry, coming down from Canada, all going counterclockwise. When it comes to precipitation, and I think I did put a question on your test this week, so hopefully you're paying close attention. Cold fronts, again, is where the lift is going to happen right on the front, so I'll use green. The rain with a cold front is going to be right on the front, so this would be where all the precip is, right on a cold front. Again, with a warm front, if you recall, I said it was like a slanted line, like a straight, low slanted line. Because this warm air and this is cold air up here, the warm air doesn't lift this air. It has to go up over top of it. The rain doesn't happen on the warm front. It's going to happen up here, out ahead of it. And so that's very important. It'll rain precipitation on a cold front, but out ahead of a warm front. So try to keep that in your head now straight. Always rains on a cold front, and it always rains or showers out ahead of a warm front as this is moving this way. The rain's ahead of it because of that slow lift. All right, so on a cold front, ahead of a warm front. And again, we went over this. The triangles and the half circles, whether it's a cold front or warm front, are always drawn on the side in which the air mass is moving. These symbols, again, are in your ESRT, so you never have to memorize the symbols. Triangles are cold, half circles warm. Stationary, remember I said it's because the cold air is pushing south and the warm air is pushing north. So they're alternate, but on opposite sides. And then there's the occluded because the air masses are both moving in the same direction. So it looks like stationary, except the symbols are on the same side. This is actually off of Regents. So there was a question it was on a short answer. They gave the students this line right here. There's a blank line. Notice they gave them continental polar. So that's cold air coming down from Canada. Here's your maritime tropical coming in out of the Gulf or the Caribbean. And it said on the frontal boundary line, right here, that's your front, draw the weather symbol to represent the front moving toward the southeast. So that was for a point. So they're saying, all right, if it's they gave me arrows to show, hey, this is cold air pushing toward Florida. That would be if it's CP, cold air, it's got to be a cold front. Remember, cold air is moving. That means it's a cold front. So the students had to go to their reference table and say, oh, cold front is triangles. And it's drawn on the side in which it's moving. So in this case, it's heading toward Florida. The students just had to use a pencil and draw a bunch of triangles facing Florida, pointing toward Florida, like that. I don't remember. I don't think they took off if you didn't shade them in. I mean, it's nice to shade them in so the kids use their pencil. You wouldn't have a colored pencil, but on a Regents, but you would use your regular pencil and just kind of shade them in. If the student didn't shade them in and just do the triangles, that's okay too. And then this was a follow-up question. On the same map, place an X centered on the geographic region. That's where an air mass comes from, right? Its source region. That was the source of the warm, moist air, the maritime tropical. So in this case, you could have put the X in two places because warm, sticky air has to come from a warmer body of water. So the student could have put the X here in the Gulf of Mexico. They could have put the X, actually I would have taken an X even down here, or an X up here in the Caribbean, anywhere down here. You don't want to put an X up here because you're way up in New England. That's cold. That's maritime, but it's polar. I suppose you could have put an X over here in the southern part of the Pacific, but being that the front's in this side of the country, I would have stuck with these areas. I don't remember if this question allowed an X over here. I would take an X if an X was over here as well. I think most earth science teachers would. But these would have been the better answers. Gulf of Mexico, Caribbean, somewhere in this general area. And I think that's it. Yeah, this front doesn't work. It was an animation, and I checked it before. It doesn't work. So that's it for this video. Again, please make sure you watch this video. Go back and understand the fronts, especially that a cold front looks like an arc and a warm front looks like a straight slanted line. So this is a cold front. This is a warm front. Go over all the fronts again. And I would look at this video before you take that test because there are some questions on that. And I will talk to you soon. Bye.